Today our lecture about bending of light in gravitational field. Application of Schwartzschild solution and GTR. As the next application of the geodesic equation with the Schwartzschild solution, we consider the important issue of propagation of the light in the gravitational field of the sun. Taking the gravitational field given by the Schwarzschild metric, since the photon is massless and distance covered by the simplicity ct, c into t, so we have the null geodesic d square equal to 0. So the orbit equation given by the orbit equation d square u divided d phi square plus u equal to gm a square plus 3 gm c square u square, where u is a 1 by r. So for null geodesic a and b tends to infinite, so the geodesic equation becomes d phi square plus u equal to 0 plus 3 gm c square u square, and we have d square u d phi square plus u equal to 3 gm c square u square. This is the equation for a and b tends to infinity. Describing the propagation of the light in the gravitational field of the sun. So we have for the, let us first neglect the right hand side, and above equation would be d phi square u plus u equal to 0 and u equal to 1 by r, so d square u d phi square 1 by r plus 1 by r equal to 0, and we solve that equation and we have 1 by r equal to 1 by r naught cos of phi plus phi naught, where r naught and phi naught are integral constant. In the order to understand the physical meaning of r naught phi naught, we have r naught equal to r cos of phi plus phi naught, and we can expand. We have cos of phi plus phi naught, we have cos of phi naught minus sin of phi naught. As we considering the equatorial plane, we have identifying x equal to r cos phi and y equal to r sin phi, so that the equation r naught equal to x cos phi naught minus y sin phi naught. Replace this value and this value, which is y equal to x cot phi naught minus r naught cosec phi naught. The equation for the straight line of the slope. So this is the equation for the straight line, and the slope is tan pi by 2 minus phi naught. The line makes an angle pi by 2 minus phi naught with the x-axis with the sun as the origin, and y-intercept is minus I naught cosec phi naught. This is the y-intercept. So from this we can see that the perpendicular distance from the sun to the straight line is r naught. Now the term 3 gm divided c square is very small. For simplicity, phi naught equal to 0 we can take. So we have 1 by r equal to 1 by r naught cos phi. So we can write the equation, the orbit equation, plus u equal to 3gm c square u naught square cos square phi. And the solution of the equation is u equal to u naught cos phi plus gm c square u naught whole square plus sin square phi. क्योंकि cos square phi equal to क्योंकि so cos square phi, the total solution of that equation is u equal to u naught cos phi gm c square u naught 1 plus sin square phi. This is the whole solution. So the second term of the right hand side, this is the second term of the right hand side, is general relativistic correction. Without this term, at r tends to infinite, we have cos phi equal to 0. So phi equal to plus minus pi by 2. Corresponding to the undeflected straight line, to value of the corresponding incoming and outgoing. So general relativistic correction is the term is this term. So we have gm u naught square divided c square cos square phi minus u naught cos phi minus r tends to infinity, so u tends to 0, g tends to 0. So we have u cos phi and gm c square u naught 1 plus r, and sin square phi is 1 minus cos square phi, and we take on the left hand side we have gm u naught square c square cos square phi minus u cos phi minus 2 gm u naught square c square equal to 0. Okay, क्योंकि sin phi equal to sin square phi 1 minus cos square phi. This is a quadratic equation and we apply Sridhar-Acharya rule. So cos phi equal to c square 2 gm u naught 1 plus minus root under 1 plus 8 g square m square u naught square divided c to the power 4. Clearly the negative sign is the meaningful choice, so we can find cos phi approximately minus 2 gm u naught divided c square, and corresponding to phi 1 comma 2 equal to plus minus pi by 2 plus 2 gm u naught divide c square, and the angle of the direction approach and departure, the angle of deflection of the sunlight is delta equal to phi 1 minus phi 2 equal to 4 gm divided r naught c square. This is the deflection. Now g equal to, using g equal to 6.67 into 10 to the power minus 11 meter cube kg inverse 10 to the power minus 2, m naught mass of the sun 1.988 into 10 to the power 30 kg, mass of the sun r naught is the radius of the sun 6.96 into 10 to the power 8 meter, and c is the velocity of the light 10 to the power 8 meter per second. We can find delta equal to 1.744 arc per second. So the prediction of the bending of the light by the gravitational field of the sun as using by the spherical symmetric solution of G mu nu, and corpuscular aspect of the light, a wave theory treatment give the same result. So in view of the slow rotation of the sun, we conceivable the angular momentum might be coupled with the spin of the photon, the effect not to be considered. And in the order of the observation of the bending of the light gravitational field of the sun, one has to make the special effort to overcome the brightness of the sun, Nature provides the scenario to the solar eclipse. So Dyson, Arthur Eddington, and Davison made the historical expedition of the Sobral. And this is the northeast of the coast of the Brazil, principal in the Gulf and Guinea, and approximately the volume delta volume equal to 1.98 plus minus 0.12 and 1.61 plus minus 0.31 arc per second. So this is the Einstein prediction is 1.744 approximately arc per second. This is the spectacular event brought of the worldwide frame of the Einstein. After 1999 measured the made to the good agreement of the prediction, deflection of the quasar 3C279 by the sun and measured in 1970-71 found to be the agreement this result. And Newton theory predict half of the value of the delta. So GTR is the great agreement. Okay, thank you. Like, share, subscribe. Okay.